All right. So last time we went over sequences. And do you remember that a sequence is pretty much just like a list of numbers that follows a pattern? Okay, so if you want to fill in that first blank there, it's just they follow a pattern. Okay, and then remember, sometimes we call that pattern a function rule. But basically, it's just like the formula that you would use to get each number in the sequence. Well, what we're doing today is a series. And basically, a series is a sequence, but where you add up all the numbers. So this would be the sum of a sequence of numbers. Okay, so you're going to notice this little weird kind of giant E looking symbol. Okay, this means summation. This is the number that you're going to start your sequence at. And then this is the number that you're going to stop your sequence at. And so you're going to start at the bottom number, stop at the top number, and then once you have the full list, you're just adding those bad boys up. That's the only difference from last time to today. So take a look at number 1. Okay, my formula is 3i minus 1. I'm going to start at the number 1. I'm going to stop at the number 6. So let's start by plugging in 1. A little 1 equals 3 times 1 minus 1. Now, obviously, I tried to pick numbers that you don't really need a calculator for. Okay, but if you typed that in, 3 times 1 is 3, take away 1 is 2. Next number is going to be A2. 3 times 2 minus 1. What's 3 times 2? 6, take away 1 is 5. A sub 3. 3 times 3 is 9, and then take away 1 is 8. Okay, if we could, just for right now, let's put computers away. Okay, we don't need those out. Our notes won't take that long, and then you'll be able to have them out later. Okay, A sub 4 is 3 times 4 minus 1. So notice I'm just swapping out what number is in my I spot. Okay, 3 times 4 is 12, take away 1 is 11. Now, let's just kind of look at this. What's the pattern? What are they doing each time? They're just adding 3 each time. Now, how many more numbers do I have to go? My start number is 1. What's my stop number? 6. So I only need to find 2 more. So A5 and A6. But now that I see what the pattern is, I'm just going to add 3 each time. So what would the number be after 11? 14. And then after that would be 17. Okay, then remember the little big E symbol means summation. So you're going to take those numbers and add them up. So in your calculator, add up 2 plus 5 plus 8 plus 11 plus 14 plus 17. Okay, and just take those 6 numbers that you got in your sequence, and if you add them up, that's what a series is. Okay. Plus 17. Did y'all get 57? Yeah. Perfect. Okay. Now, rather than, let's say that it's kind of a long list. Okay. Let's say it's not like a little short, quick list. There is a formula that you can use to find this without having to write out the whole list and add up all the numbers. Your formula is right here. Okay, So A1 and AN are going to be the first number in the list and the last number in the list that you want to stop at. So in this case, what's the first number and the last number that I added up? 2 and 17. So let me write the formula down here and then we'll plug in the numbers. So this would be 2 plus 17. This is the first number in the list and the last number in the list. And then after you add them up, you're going to multiply by n over 2, where n is the number of numbers in the list. So we had 1, 2, 3, 4, 5, 6. So that would be a 6 over 2. Now 6 will divide by 2. What's that? 3. So then really I'm doing 3 times, what's 2 plus 17? 19, and 3 times 19 also gives me what value? Okay, it also gives me 57. Okay, which you'll notice is the exact same answer that we got when we did it the long way by generating the list. So let's practice using that formula just a couple more times to make sure that you got it. Okay, take a look at number 2. Remember, I'm going to do first plus last. So what would that be for example 2? 3 plus 38. And then on the outside, I'm going to times by n over 2, where n is the number of numbers in the list. So let's just count them up. 1, 2, 3, 4, 5, 6, 7, 8. Then I would put 8 over 2. What is 8 divided by 2? 4. And then 3 plus 38 is 41. What is 4 times 41? 164. Very good. And if you were to add up all of the numbers in the list, you should also get that. Yeah? Okay, one more left like that. Set up your formula for me, please. Remember, it's n over 2, A1 plus AN. A1 and AN are the first and the last numbers in the list. So that'd be what? 8 plus 1, 16. And then count up how many numbers and divide by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'd be 10 over 2. 10 divided by 2 is 5. 8 plus 116 is 124. And then if you multiply that by 5, you get 620. Okay, and if you added up all those numbers the long way, you should get that exact same answer. Okay? All right, go ahead and turn the page. Okay, and then also, I don't think I said this, but you can only use this formula right here if it's an arithmetic sequence. Do you remember what types of patterns count as arithmetic? Plus and minus. Very good. So if it's a plus or a minus pattern, okay, if it's an arithmetic sequence, then you would use that formula. So turn the page. Geometrics have their own, but it's really just as easy as the one we just did. So turn the page and let's do it for a geometric sequence. Okay, we're going to do the first one by hand, then we'll check it with the formula. So what is my start number for this question? Okay, we're going to start at 1, and then when are we going to stop? At 5. So my A sub 1 is going to be, I'm following this formula right here. So it's 10 times 3 to the 1. Then it's going to be 10 times 3 to the 2. Then it's going to be 10 times 3 to the 3. And then once I have that many digits, hopefully I'll be able to see the pattern that I won't have to keep plugging in the formula over and over again. So first let's do 10 times 3 to the 1. Okay, I got 30. Next one is 10 times 3 to the 2. 90. 10 times 3 to the 3. 270. Can we identify what the pattern is? What is it? Yeah, times 3 each time. Very good. And now notice, how do I know I only have to do more? Because I'm starting at 1, I'm stopping at 5. So I only need 2 more of these guys to finish out my list. So if I do 270 times 3, that gives me 810. And then if I do 810 times 3, I get 2430. Then remember, to make it a series, you just add all those guys up. So you're adding these 5 numbers up. So 30 plus 90 plus 270 plus 810 plus 2430. Good? All right. So now take a look right next to it. We can do it by hand, which kind of takes a little bit longer, or we can use the formula that's right here. Now your A in the front should have a little 1 under it, because remember, A1 is what the first term is. So it's going to be A1, 1 minus Rn, 1 minus R. Now remember that R is what you're multiplying by each time. So in this case, what's my R for my pattern? 3. And what's my A1 or my first term in the list? 30. Very good. So you would do 30 parentheses, 1 minus, what was my R? Times 3 each time. And then N is going to be the last one that you do, which is 5. And then over 1 minus 3. So remember, N is the last one. It's like what you're stopping at. Okay, and then if you'll just type that formula in, you should get 3630. So we're doing 30 times, open your pretty fraction, 1 minus 3 to the 5 over 1 minus 3. Okay, and if you want to put the parentheses, you can, but you really don't need them. As long as you use the pretty fraction, it should give you the same thing. Okay. All right, so let's skip. I guess we can do number 5. Okay, so first question, what's my A1 that I'm going to put in the front here? 1 minus R and 1. So my A1 is my first term, which I think I heard somebody say is a 3. That is correct. 1 minus. Then remember that my R is what I'm timesing by each time. It's what my ratio is. So if I go from 3 to 6 to 12 to 24, what's my ratio? Times 2. And then remember, the only number that I need to plug in is my N, and N is how many numbers are in the list. So I just have to count them up. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if you type that in, you should be able to get your answer. So it'd be 3 parentheses, or you don't even really need the parentheses unless you just want to. Then 1 minus 2 to the 9 over 1 minus 2. So if I were to add that list up, it'd be 1533. Got it? Okay. All right. Last little thing on this page that I want to show you is that although I am showing you these formulas, guess what? There's already a button for it in the calculator. So if you will please push the math button. And then I want you to scroll down until you see that weird little E symbol. It should say summation and then the weird little E. Okay, it's option 0. Then when you type it in, let's just type in number 6. Now, you do not have an I button, but just use X. So at the bottom, you're going to put X equals 0. So I'm starting at 0, I'm stopping at 4. And then when you go to your parentheses, you're going to type in your formula, which in this case is 3 to the I. So I'll do 3 to the X. And then it'll just do it for you. So 121 is the answer for that first one. And then for your calculator, or for your test, sorry, you will have your calculator. So I would say knowing how to do it by hand is great, but since you do have a button for it, why use the formula? But you could. Okay, go ahead and type in number 7. So it'd be math, scroll all the way down to option 0. Where does your summation start on number 7? X equals what? 1, and it stops at 5. And your formula is I squared, which we would type in as an X squared. Just because you don't happen to have an I button that you could use. So that one comes out to 55. All right. Then I guess I will say, if you were to get a question like a list, like on number 8, the formula is going to be easier because but I guess you could also just add up all the numbers and that would be just as easy. Okay, good. All right, turn to the very last page, almost done. Okay, when you have a series, remember what we said, a series means you have a list, you're adding them all up. Okay, if you take your list and you make it go on and on and on to infinity. So essentially you're saying you're not going to have a stop number. Your stop number is to infinity. Okay, when you do that, if your R is less than 1, your list, even though it goes on and on and on forever and ever and ever, is going to converge to a particular value. Okay, and you can find that value using this formula right here. If you have an R that is bigger than 1, then when you add up all your numbers, it's going to go to infinity or diverge. So that means not going to a certain value. Okay. So here's what I mean by that. Take a look at number 9. First question we need to decide is it converging or diverging? Converging means that as you add up all the numbers, they're getting closer and closer to a certain value. Diverging means it's just going to infinity. So if I add up 1, then 2, then 4, then 8, then 16, what's the pattern? How are they getting those numbers in the list? They're doing times 2. Is 2 bigger than 1 or smaller than 1? Bigger than 1 means it's diverging. You cannot find the sum. Okay, it's going to infinity. Okay, take a look at number 10. Try to find the pattern for me. Goes from 27 to 9 to 3 to 1. What's the pattern on that one? Dividing by 3, which means my ratio is 1/3. Is that bigger than 1 or less than 1? Less than 1 means it's converging. And that means that even if I let my list go to infinity, my numbers are going to be approaching like one specific sum. So we're going to use this formula right here to find it. So it says A1 over 1 minus R. What does A1 stand for? First term, which is what number? 27 over 1 minus R is your ratio, which is what? 1/3. And then just type it into the calculator. So pretty fraction, 27 over 1 minus 1/3. Okay, what'd you get? 81 over 2. And 81 divided by 2 is 40.5. It doesn't really matter. Either one would be fine. I'll box both. Okay, but remember, you only have to do that step if your series is converging, which means your R is less than 1. All right, one more, 2 more left like that. Take a look at number 11. What's the pattern? I go from a half down to a fourth. It's dividing by 2 each time, which means your R is a half. Is that bigger than 1 or less than 1? And if it's less than 1, that means it's what? Converging. And if it's converging, that means you are going to get an answer. So follow your formula. It's A1 over 1 minus R. A1 over 1 minus R. In this case, what's my A1? The first term is a half over 1 minus, my R is also a half. And then what do we get for that? 1 is correct. Okay, now, if you don't believe me, just watch. I'm going to do this one by hand. So a half is 0.5 plus a fourth would be 0.25 plus an eighth. I actually don't know what that is. Okay, and then a 16th. Now, it may not be exactly 1, but do you see how it's going to inch closer and closer to 1 as you keep adding those terms up? So the more numbers in the list that you go to, which remember for an infinite series means you're going to add infinite numbers. The more numbers you get, the closer you're going to get to this goal. Okay. All right, last one. What's the pattern? 1, -3, 9, -27. What are they timesing by each time? -3. Now, you don't care about the negative, you care about the 3. Is it bigger than 1 or less than 1? Bigger than 1. Then does it converge or diverge? Diverge, that means no sum. Okay? So if the number, even if it's negative, you don't care about that. The 3, because it's bigger than 1, that means it diverges, you're not going to get an answer. Okay? Only if the R is less than 1. So it could be a fraction or a decimal. Okay, that being said, you don't have a Delta Math today because remember what we talked about on Monday? You guys take a mini test over this on Friday. This is your last test going in for this quarter. So I'm going to give you the review. Okay, it just covers today and last time. Okay, so you do not have a Delta Math today. You just have your test review and then you'll take your test on Friday. So, okay, you do not have to memorize any of the formulas. They'll all be on your test for you already.